Hello world, it's Team 5 Star from IIT Guwahati. So we present our work on using Azure Blockchain Platform for secure voting for codefundo clusters 2019. In the current scenario, people have to vote through EVM machines. We can use blockchain tech to make the whole process online such that people can vote securely from anywhere. But what about the places where people do not have access to internet? Out of 1340 million people, only 627 million have access to internet in India. That's roughly 50%. So how will the other people vote? So we came up with our own implementation of blockchain that can be deployed in a private network and it runs securely offline. Such networks can be deployed in local polling stations in cities, villages and also in remote locations. Later on, the offline chains can be merged to the main Azure blockchain that collects the online votes throughout India. The private network passes encrypted messages and multiple nodes can be added easily such that there is no single point of failure. So let me walk you through our implementation. So as you can see, this is hosted in localhost. So as it is going to be an offline station. So this is the backend. Currently we do not have any transactions right now, and we can add other nodes. So the other PC in my network currently is 168.43.16. We can add the node and we can see the transactions here too. So next, the normal users can go to the voting page. They can show their voter IDs and cast their vote to the candidate. So we can see that we have a transaction here and we got the vote was taken. Next we can go home and if the same person tries to cast another vote, so we can see that you can spend a transaction twice. So next let us take some other voters. And awesome. So now once the two votes were done, you can go to the home page and after the local elections were done, the offline votes can be merged to the online one. So we can click on it, and so these two votes were merged to the online blockchain, which is deployed in Azure Blockchain Service. So we have also deployed an online site which is hosted in Python Anywhere right now. So here also we can check the results in real time and we can vote here also. So here the voters have to give their IDs. So as these are online users, we can send them an OTP, just another layer of security. So the OTP we got was 3413. So the vote, cast the vote. So this online transactions are completely done in Azure Blockchain Service. So we can go home and now we can check the results. So here are the results right now. So that's 15, it's 11. So I can show you that merging part once again. So these are the current transactions right now. We can go to home, we can cast another vote. So we can cast. So currently Uday has 15 votes. And give another transaction. We can submit. Go home. And now we can go to merge the votes. So currently the merge happens. So the offline transaction happened in our blockchain and it was merged to Azure Blockchain Service. And now we can reload and you can see that the number of votes got increased in real time. So now we can discuss some limitations, or we can address some problems. So what if someone tries to vote in an offline station and tries to vote online too? First of all, if the local stations have internet connectivity, the private chains will be merged with the global chain, and hence user's second vote will be discarded. If the local station doesn't have internet and the user votes online, when the offline chain is merged to the global chain, the offline vote will be discarded. Similar trend follows when any voter tries to vote in two different offline stations. Security in offline stations is still needed, but as there will be multiple nodes in the network, there is no single point of failure. So that's how we have addressed the problems. So that's all from Team 5 Star from IIT Guwahati. Thank you.